Now we're going to do some exercises. Let's start with problem one. So in problem one, you are facing two investments, project A and project B, and you were given some informations. The first informations is this initial outlay for both investment. Project A has the initial outlay of 300,000, and project B has the initial investment of 40,000. You're also given the information regarding the future cash flows for both investments and the discount rate or the required rate of return for both project, which is 15%. And now you're asked to calculate or to find the payback period, discounted payback period, NPV, IRR, PI, and MIRR. And then you have to choose one of the investments you think is the best regarding to your calculations. Okay, now we're going to do the first method, which is payback period, and we're going to calculate the project A first. The first step is to list the year of the project and then list the cash flow of the project, and you do the accumulated cash flows by accumulate each year cash flows. For the first year, the accumulated cash flow is still 20,000, but for the second year, you add this 20,000 with the second year's cash flow, which is 50,000, and it becomes 70,000, and so on until the fourth period. And then the next step you have to do is to find where is your initial outlay, which is 300,000 for project A, and your 300,000 is actually in between the third and the fourth year, because your 300,000 is in between 120,000 and 510,000, right? So the next step, I'll mark this, and the next step is to use this formula, and to use this formula after you find your 300,000 is in between the cash flow of the year 3 and the year 4, is to write down the earlier year, which is the third year. You write down the 3 here plus your initial investment, which is 300,000 for project A, minus the accumulated cash flow of the earlier year, which is 120,000, divided by the cash flow, the only cash flow, not accumulated one, but just cash flow for the year 4. So it is 390,000. And you need to calculate it, and you get the 0.46, and then it means that the payback period of the project A is 3 plus 0.46, which is 3.46 years. And we're going to do the same with project B. You list the year of the investment, and then you list the cash flows, and you accumulate all the cash flows with the same method that I have told you earlier. And then we're going to look for where is our initial investment, which is 40,000 for project B, is in between. And it is in between the cash flow of the second year and the cash flow of the third year. I'm gonna mark this. And it's because the 40,000 is in between 31,000 and 49,000, right? And then the next step is to write down the earlier year, which is 2, the second year, plus your initial investment minus the accumulated cash flow from the earlier year, which is the second year, and it is 31,000, divided by the cash flow of the third year, which is 18,000. And then you calculate it, you get this 0.5, and it means that the payback period of project B is 2 plus 0.5, and it becomes 2.5 years. Okay, and after that, we can see that the payback period of the project B is shorter than the project A, 2.5 years. compared by 3.46 years. It means that the project B is more preferable to the investors. It means that based on the payback period, we're gonna choose project B. Okay, and then the next one is for discounted payback period. Actually, the technique is the same with payback period, but in discounted payback period, you're not using just your cash flow, but your present value of cash flows. Okay, so the first thing, you have to list the year again, and then you calculate the present value of cash flow for each year. For example, here the present value of cash flow for the year 1, it is the cash flow of the year 1 of project A, which is 20,000, divided by 1 plus the required rate of return or discount rate that is stated in the question, in the power of 1, since we're calculating the cash flow of the year 1 of the project A. So in the power of 1. And then we get this number. We do the same with the others, and then we accumulate again the present value of the cash flows. And then we're going to look for our initial investment. 300,000 is in between the 3rd and the 4th year. Again, the same with payback period for project A. Because the 300,000 is in between 88,074.3 and 311,058.07, right? And then the next step, you have to write down the earlier year, which is the 3rd year. So 3 plus your initial investment, 300,000, minus the accumulated cash, present value cash flow from the earlier year, which is the 3rd year, and it is 88,074, sorry, divided by the present value cash flow of the year 4, and then you calculate it, you get this number 0.95, and the discounted payback period for project A is 3 plus 0.95, which is 3.95 years. We're gonna do the same again with project B. You list the year here, and then you make the calculation for present value of the cash flows. I'm gonna give you an example again. For the present value cash flow for year 1, this is the cash flow of the year 1 of the project B, divided by 1 plus the required rate of return or discount rate, which is 15%, in the power of 1, since we're calculating the cash flow of the year 1 for project B. And then we get this number, and we'll do the same with this remaining cash flows. And then we make the accumulated cash flows, and we're gonna look for our initial investment for the 40,000, and 40,000 is in between the 3rd and the 4th year. Okay, so the next step is to write down the earlier year, which is 3, the 3rd year, plus your initial investment minus your accumulated present value cash flows of the earlier year, and divided by the present value of cash flows for the 4th year. And then you got 3.03 plus 0.43 for the payback period of the project B. It means that the payback period for project B is 3.43 years. And if we take a look in discounted payback period, the discounted payback period of project B is shorter than the one in project A. It means that we're gonna choose project B based on the discounted payback. Okay, and then for point C, we're gonna calculate using the NPV method. I'm gonna remind you a bit that the NPV is the sum or the sigma of the present value cash flows, which is cash flows divided by 1 plus R, or the required rate of return, in the power of I, and we subtract it with the initial investment. Okay, so the first step, the initial investment is already given in the question, which is for project A is 300,000. And now we're going to calculate the present value cash flows. With the formula, cash flow divided by 1 plus R in the power of I, like this. So the present value cash flow for project A is the cash flow of the year 1 for project A divided by 1 plus the required rate of return, which is 15% in the power of 1, because we're calculating the first year of the cash flow, yeah, and plus the cash flow of the year 2 divided by 1 plus the discount rate, or the required rate of return, which is 15%, again the same, in the power of 2, because we're calculating the cash flow of the year 2, and so on with the year 3 and the year 4. And then we get the sum of the present value cash flows for project A is 311,058.07. And then to get the NPV, we're going to subtract the present value cash flow with the initial outlay, and we get our NPV of 11,058.07. We're going to do the same again with the project B. We're going to calculate the present value of cash flow first. So for the project B, this is the cash flow, the cash flow of the first cash flow, the first year cash flow of the project B divided by 1 plus the required rate of return, 15%, divided by 1, since we're calculating the cash flow of the year 1, plus the second year's cash flow, which is 12,000, divided by 1 plus the required rate of return in the power of 2, because we're calculating the cash flow of the year 2, and we'll do the same way with the third and the fourth year. And then we get our sum of PVCF is for the 3,434.16, and then we get our NPV by subtracting the sum of PVCF and the initial outlay, and we get the NPV 3,434.16. From the NPV, we can conclude that the NPV for both projects, the NPV have positive value, which means both of the project is profitable in the future. But when we are about to choose only one, the NPV of the project A is higher than the NPV of project B. It means that we are going to accept project A based on its NPV.